So yeah, dear students, now this question is from Trigonometry, chapter 6. Prove that root of 1 minus sine theta upon 1 plus sine theta is sec theta minus tan theta here. You know, this question is from 6.1. Now, when such a question comes here, you can start from the left hand side or you can start from the right hand side here. So in this case, we're starting from the left hand side to prove the right hand side here. So when such a question comes here, you start either with the left hand side or with the right hand side here. So I'm starting in this case with the left hand side here. Root of 1 minus sine theta upon 1 plus sine theta. Now in the very next step, okay, what you have to do? You have to multiply and divide the denominator here. Okay, but use this conjugate, using the conjugate here. So what is the conjugate of the denominator? 1 minus sine theta upon 1 plus sine theta. The denominator is 1 plus sine theta. The conjugate of denominator is what? 1 minus sine theta. Plus, the conjugate is minus. If this is a plus b, the conjugate is a minus b. And if this is a minus b, the conjugate is a plus b. So just take the opposite, that is the conjugate here, and multiply and divide here. Now once you have done this here, then the next step, now multiply here. Now what is a minus b into a minus b? That is 1 minus sine theta into 1 minus sine theta. 1 minus sine theta the whole square. Okay, so once again, see here in the numerator, both the places you have the same binomial. So it becomes 1 minus sine theta the whole square. And in the denominator, you can see it is a plus b into a minus b here. So a plus b into a minus b becomes 1 minus sine square theta, right? 1 ka square, 1 sine ka square, sine square theta. So a plus b into a minus b is a square minus b square. So just mention the identity over here, since a square, sorry, it is a plus b into a minus b. It is what? A square minus b square. Okay, so this is not there. So a plus b into a minus b equals to a square minus b square. And once you've applied that, you go for the next step here. What is the next step here? 1 minus sine theta the whole square remains as it is. And 1 minus sine square theta, according to the identity, becomes what? Cos square theta. So state the rule here also. Since sine square theta plus cos square theta equals to 1, therefore cos square theta is nothing but 1 minus sine square theta. Then what? You have to find what the square root here. So I think when you're finding the square root, you don't have to give what this square root sign here. Am I right here? Okay, so just apply. So finding the square root in the next step here. So what is the square root of 1 minus sine theta? The whole square root is 1 minus sine theta. 1 minus sine theta, the whole square becomes 1 minus sine theta, and cos square theta becomes cos theta. So we have found the square root here, because we can see perfect squares inside the square root. And then you separate the common denominator for both the numerators here. So 1 upon cos theta minus sine theta upon cos theta. Separate the common denominator for both the numerators. So cos theta is the common denominator. So 1 upon sine theta minus sine theta upon cos theta. And once you have done that, just convert into its reciprocal here. 1 upon cos theta is nothing but what? Sec theta. And you know sine theta upon cos theta is what? Tan theta. Okay. So that was the question. Sec theta minus tan theta. And we got here sec theta minus tan theta here. You can see over here. Sec theta minus tan theta. And we got the answer sec theta minus tan theta here. So equals to, which is what? Right hand side. And then end your question that therefore root of 1 minus sine theta upon 1 plus cos theta, 1 plus sine theta equals to what? Sec theta minus tan theta. And then you write hence proved at the last year. Just because there is no space, you can use the next page here. Hence proved at the last year. So this is the sum here. Very easy. You start with the left hand side here. Use the conjugate of the denominator, multiply, divide. Then a minus b into a minus b becomes a minus b the whole square, and a plus b into a minus b is a square minus b square. Apply the identity, and then 1 minus sin square theta becomes cos square theta, and then you find the square root because these are perfect squares inside the square root here. So 1 minus sin theta the whole square becomes 1 minus sin theta. Cos square theta becomes cos theta. Separate the common denominator for both the numerators, and 1 upon cos theta is sec theta. Sin upon cos is tan. That is equals to nothing but the right hand side, and then mention the question hence proved here. So I hope you have understood here.